Welcome back. Hope you had a good lunch. And welcome to this first talk in the session on international collaboration. My name is Carsten Sørlie from Equinor. I'm the project lead on our technology initiative on geothermal energy in the research center in Equinor. Today I'll talk about the GEOTHERMICA program and a project that we are involved in. So I'll start by an introduction to GEOTHERMICA and then continue with some information on the DEEPEN project. To start with GEOTHERMICA. The GEOTHERMICA is a program or platform for international collaboration where the objective is to promote research and innovation in geothermal energy in order to make geothermal energy a reliable, safe and cost-competitive alternative in the energy transition. Targets innovation in geothermal energy supply and also the integration into the future energy system in Europe. Geothermal comprises 3 technological themes and 4 cross-cutting non-technological thematic aspects. The technological themes cover the assessment of geothermal resources, the development of these resources, and supply and smart integration into the energy system and the operations. The cross-cutting aspects are connected to environmental, social, and economic sustainability, data statistics and knowledge sharing, political awareness, education, and strengthening the geothermal sector, and finally, on policy, economy, and risk mitigation, and also the regulatory framework. There are currently 20 geothermal energy research and innovation program owners from 16 countries in Europe and the US. For the second call, I'll get back to the call structure, but for the second call that was initiated in 2019, Norway, through the Research Council of Norway, joined together with US and the Department of Energy. There has been already initiated project from 2 calls within GEOTHERMICA. The first call was in 2018 and resulted in 8 projects with a total cost of 44 million euros and GEOTHERMICA funding of 24 million euros. A second call came out in 2019, resulting in 7 projects. At this time, Norway had joined GEOTHERMICA together with the Department of Energy and the US. The total financing for the second call was 39 million euro, and with GEOTHERMICA providing 24 million euro in funding. There are actually 2 projects that have Norwegian partners in them, funded by the Research Council of Norway. And that's the DEEPEN project with Stiftelsen Norskar and Equinor as partners, and TESTEM with SINTEF and Equinor as partners. In DEEPEN, Equinor is the national coordinator with Reykjavik Energy as the main coordinator for the consortium. And in the TESTEM project, SINTEF is the national coordinator, the contract partner with the Research Council of Norway, and with Brookhaven National Laboratory in the US as the main coordinator. There is actually a third call out now, due with a pre-proposal on 4th of October, with a focus on accelerating heating and cooling transition, based on climate neutral resources and a resource efficient and sustainable distribution, storage and utilization of heating and or cooling. And finally, integration of the heating and or cooling in the local regional energy system. It's indicated a total funding by this joint effort by Smart Energy System GEOTHERMICA of 32 million euros for this call. And the Research Council of Norway have committed to 1 million euro in this call. As I mentioned, pre-proposals are due on October 4. That's mainly a check of eligibility for the individual national countries, but also to look jointly the different funding bodies on how this fits into the overall strategy. If you're approved for submitting a full proposal, this is due by end of January next year. Expected project start is most likely mid-2022, but no later than December 2022. And then to the DEEPEN project. DEEPEN stands for De-risking Exploration for Geothermal Plays in Magmatic Environments. The aim of the project is to reduce the resource risk and upstream exploration costs by increasing the probability of success when drilling for geothermal fluids in magmatic systems. The scope for the project is to develop a PFA methodology or play fairways analysis methodology specific to magmatic plays. That includes also the root zones of geothermal systems in magmatic environments. This means that we're also targeting the deeper magmatic systems and also the super hot or supercritical resources we may find. The target is also to develop new tools that will help with the subsurface imaging of deep and hot bodies, and also building then on the Framework 7 project, the IMAGE project, where several of the current partners were involved. And finally, to demonstrate the play fairway analysis methodology at the two magmatic systems, one at Hengil in Iceland, operated by Reykjavik Energy, and the other at the Newberry volcano in Oregon, in the Cascades here. The DEEPEN project has a total budget or cost of 3.7 million euro, where GEOTHERMICA provides about 2 million euros in funding. The Norwegian effort within the project is 7.5 million Norwegian kroner, of which 3.5 is provided as funding by the Research Council of Norway. So what is play fairway analysis? It's a methodology adapted from the petroleum industry that integrates data to find favorable plays for exploration in a systematic way. Equinor have applied it in our global exploration for identifying where to actually drill our exploration wells, trying to have an objective evaluation of which wells to drill in a year. It's been used in regional scale prospecting efforts and uses fairways to identify opportunities for further exploration in the 2D horizontal space. In the DEEPEN approach, we want to identify fairways in both the horizontal and vertical space, making it applicable for both regional scale and project scale opportunities. And then use PFA to guide exploration for multiple resource targets in magmatic settings. It means that we want the DEEPEN methodology to cover conventional hydrothermal systems, supercritical fluids, superheated steam, and also enhanced geothermal systems. The play fairway analysis methodology from oil and gas is based on three play factors as we define them in Equinor. It's the source for oil and gas resources, it's a reservoir, and it's the trap seal for a reservoir, or the container, as we call it in oil and gas. Or equivalent, we customize this for geothermal, and we have three play factors identified here. One is the heat source, the other is how an opportunity or the recharge for this geothermal opportunity, and finally producibility, or here again the container. So it's a similar way of approaching this, trying to have a way of ranking opportunities on a broader scale. The project objective in DEEPEN is to improve and benchmark both the exploration techniques and modeling methods for supercritical and superhot geothermal environments. Work has been done on PFA and geothermal previously in the US, but what's novel in this project is actually the focus on the superhot, supercritical geothermal system close to the magmatic body. We have defined 6 technical work packages in the project. 3 of them aimed at progressing TRL in the project for the methodology, and 3 supporting technology work packages. The work packages for progressing TRL is focused on extending the PFA methodology to better represent magmatic plates. It's on applying the methodology that we sketch out on 2 cases, one in the Newberry volcano and the other in the Hengil area in Iceland. And finally, the final work package 7, is aimed at trying to make what our findings in the project and demonstrated in the case study into a more generalized technology or methodology for these magmatic plates. The 3 supporting work packages addressing how to extend exploration tools, existing exploration tools for deeper and hotter resources, and to obtain better understanding of superhot geothermal systems, and finally to apply recently developed exploration methods in these kind of systems by testing them out, demonstrating them on the planned IDDP-3 reservoir in Hengil. IDDP is the Icelandic deep drilling project that is ongoing, and where its planning for a 3rd well is in progress. The DEEPEN has 10 partners from 6 countries. Reykjavik Energy, the main coordinator from Iceland, together with ISOR, the Icelandic Geological Survey, and the University of Iceland. Equinor and Stiftelsen Norskær from Norway, NREL and Lawrence Berkeley National Laboratory from the US, IFP Energie Nouvelle from France, and GFC Potsdam from Germany, and finally ETH in Zurich from Switzerland. Key to this project is the training sites and actually then demonstrating how we can use the data from these training sites in the application sites. We have actually been able to define training sites from all over the world. The main part of the data used for training is from Iceland and the US, but fortunately enough, we have also gotten other data from other magmatic plates, hopefully spreading out and for laying a basis for a more generalized approach to this methodology. As I mentioned several times now, the application sites are the Hengil area in Iceland, operated by Reykjavik Energy, where we want to target exploration and also how to actually identify the best target or sweet spot for a future IDDP-3 well. In the Newberry, in the US Cascades in Oregon, we're targeting exploration. So, the main takeaways here. I would like to promote the GeoThermica AeroNet platform as an excellent place actually to search for and establish international collaboration with competent partners through the national funding bodies that are dedicated to the GeoThermica objectives. And I would also like to emphasize what we consider the importance of actually going through with a project like DEEPEN, reducing the exploration cost for these kind of magmatic systems, and also targeting the super hot geothermal resources that we have been working on in several projects now over the last couple of years. But also to be able to engage in a project where we are customizing oil and gas technology for the geothermal application. Finally, I would like to acknowledge the Research Council of Norway for funding the DEEPEN project and our engagement in the DEEPEN project, and also the Research Council of Norway as the national funding agency for the second GEOTHERMICA call and the upcoming joint GEOTHERMICA Smart Energy Systems call. And with that, I would like to end my talk, and I'm open for questions. Thank you very much.